Yes.
Okay. All right, so the unit that we're starting, yes, you guys all remember the Pythagorean theorem. You learned it as a freshman. It is going to help us with the new concepts we're going to talk about today. Okay, so first things first, let's go ahead and remind ourselves what is the Pythagorean theorem. Okay, so I'm going to go ahead and just write it up here. What is it, Jameson?
A squared plus B squared equals C squared.
A squared plus B squared equals C squared, but let's provide some context to that. Okay, what in the world is it even talking about? So we use Pythagorean theorem when we're trying to find missing sides of right triangles. Okay, Pythagorean theorem works for right triangles. Okay, so, and you guys remember that we have our sides, our A, B, and C. Which side has to be C? Remember, that's the important side.
The one with the little tiny triangle, or the square in the corner.
Yes, okay, I would be so impressed if you remember the name. It starts with an H.
Hypothesis.
Very close. Hypotenuse.
I was so close.
Okay, so this guy has to be our C. The hypotenuse is always the C. Okay, A and B actually doesn't matter. Okay, that guy could be B, that side could be A, but the hypotenuse has to be C. Okay, so once we know A, B, and C, we just plug it into our theorem. You guys remember that a theorem is just something that has been proven. It works every single time. Okay, so let's go ahead and look at number 1 then. Okay, for numbers 1 through 4, we're just trying to find the missing sides of these right triangles. Okay, so we got to use Pythagorean theorem. Okay, so go ahead, somebody raise your hand. Tell me, what is my A, B, and C for number 1, Lily?
Is C 13?
Yes, ma'am.
And then A, and then B, X.
Beautiful.
Why is X gonna be B and why is C gonna be 13? Is it just because it's longer?
So C, always think that your right angle is pointing to your hypotenuse.
Oh, okay.
That is your C. Okay, remember A and B can be either one of these sides, doesn't matter. Okay, but Lily chose 7 for the A, X for the B, totally fine. Okay, so now that we know A, B, and C, let's go ahead and plug it into our theorem so we can solve for our missing side. A squared, 7 squared, plus B squared, we chose X for our B, X squared, equals C squared, 13 squared. Okay, it is not just A plus B equals C, it is A squared plus B squared equals C squared. Okay, well now it just becomes a matter of solving for X. Okay, so first of all, let's get rid of these squareds. Let's simplify it, make it prettier. We know what 7 squared is. What is 7 times 7?
14.
Oh,
Oh, wait, no, 7 times 7, my bad.
49.
Oh, why did I say 20?
49. Can we square a number we don't know? So can we simplify X squared?
No.
No, we don't know what X is, so that just has to stay X squared for now. Okay, what is 13 squared, or 13 times 13?
It's 9.
13 times
169.
169. Okay, beautiful. Okay, so we're just solving for X. We're trying to get X by itself. So look at our side with our X. What do I need to get rid of or move first, the 49 or the squared? Why the 49?
Because it doesn't have the X.
It's farthest from my X, okay? So opposite of a positive 49, we're going to subtract 49 from both sides.
Ouch.
Okay, so I still have X squared. Help me out, what is 169 minus 49? What are we gonna get? What is it?
29? Yes.
Ooh. 169 minus 49?
Oh, minus 49.
120.
120. Okay.
Oh, yeah.
Okay, my last step. I gotta get rid of this squared. What is the opposite of squaring something? Square root. Good. So just like addition and subtraction are opposites, multiplication and division are opposites. The opposite of squaring something is square root it. Okay, now here's the thing. I don't know what the square root of 120 is. I don't think that's a perfect square number. So let's go ahead and punch it into our calculator. Okay, square root, second button,
Oh, yeah, that's right.
x squared, gives me a little square root sign, 120.
So it would just be 10.9.
Okay, so let's practice rounding. That's a skill that we all need practicing. Okay, so let's say I want it to 2 decimal places. Okay, so if I want it to 2 decimal places, look behind it. Is the 4 gonna bump the 5 up or keep it a 5?
Keep it up. Keep it 5.
It's gonna keep it a 5. So my decimal answer, 10.95. Okay, I would love for like the sound effects and the random commentary to not be on my video anymore. So yes, please, thank you. Okay, so there's 2 ways that your assignment is going to ask you to write these guys, okay? So the first way is obviously the decimal version, where you punch it into your calculator, you get a decimal. If you see a symbol on your assignment, hint, hint, that looks like this, that means it wants the decimal version, like the little squiggly equal sign. Okay, if you see a regular equal sign, it means it wants the exact answer, which is just the square root of whatever you get. So our exact answer was the square root of 120. The decimal answer was 10.95. And it'll say like round to 3 decimal places, 4, whatever. Okay, so not a very pretty answer, right? This wasn't a whole number, but that's okay. We still solved it the exact same way. I would love if you close that door. Close it, close it, close it.
The door's
Thank you. Okay, number 2. Same way, we're just practicing over and over. Who's got my A, B, and C for this triangle, Bella?
4 plus 5 plus x.
Ooh, what's my, which side's my A, which side's, hold on. What's my A, B, and C side?
4 is A.
Mm-hmm.
5 is B.
Uh-huh.
And x is C.
Love it, love it. Beautiful. Okay, so now that we know A, B, and C, we can plug it into our Pythagorean theorem. Thank you so much. Perfect. Okay, so let's go ahead and plug it in. I have A squared, 4 squared, plus B squared, 5 squared, equals my C squared, x squared. Okay, this time my x is in a different spot. I like practicing this one. Okay, but the same steps. Let's get rid of these squareds where we can. Well, we know what 4 squared is. What is 4 times 4?
16.
16. And we know what 5 squared is. What is 5 times 5? What is it?
25.
25. Okay, can't square a number I don't know, so that just has to stay x squared. Okay, now here's where this guy is different. We're not moving things. Think x is almost by itself, almost. So we don't need to move anything. What should I do with these 2 numbers on this side, though?
Subtract.
They're like terms, so what should I do?
Combine.
Combine them, okay? It's telling us to add them over here, right? So let's just add those 2 numbers. What is 16 plus 25 gonna give me? What?
41.
41.
Gnarly. 41.
41 equals x squared. Okay, so whenever you have those 2 numbers, in fact, I'd put a star by that, combine them, okay? Don't move them. They're already both on that side. Just add them up. Now, what's my last step? How do I get that x by itself?
Dividing?
Opposite of square is
Oh.
square root. Beautiful. So we square root both sides. Okay, that gives me my x all by itself. Now, the square root of 41, remember that is our exact answer. Your assignment might ask for the exact answer. Okay, then it might ask for the decimal. So this is where you bring out your calculator. Type in the square root of 41. Okay, let's practice rounding. Let's say it wants it to 3 decimal places this time. Okay, so 3 decimal places, 1, 2, 3. Look behind the 3. Is the 1 gonna bump it up or keep it a 3?
No.
It's not gonna bump it up, so our final answer, 6.403. 6.403. So we have our exact version of the answer, and we have a decimal version. Okay, show me a fist of 5 on Pythagorean theorem. I know we've talked about this since you guys were freshmen. How are you feeling? Like, be honest. And Isaac, if you're on your phone.
Wait.
Okay, cool. Sounds like everybody's feeling pretty confident. So let's go ahead and skip numbers 3 and 4, because this is where the new stuff comes in. Okay, new stuff. Okay, so there are these things in math, in trigonometry, in geometry, that are called special right triangles. We're skipping 3 and 4. Okay, so we have these things. They're called our special right triangles. They never really change. Think they're special. Maybe they just get bigger and smaller, but we'll see how that happens in a second. Okay, so our first special right triangle that we have is called our 45, 45, 90 triangle. Okay, so draw yourself for me, you guys, a nice little right triangle, and try to make the legs, meaning these sides, as close to the same length as you can. Okay, so you have your right triangle. The reason it's called a 45, 45, 90 triangle is because here's our 90 degrees. These two other angles are both 45 degrees. Hence the name 45, 45, 90. Okay, cool. So why do we care? Okay, so we know that if these angles are the same right here, right? 45 is the same as 45. That means their opposite sides are also equal to each other. So that side is equal to that side. Okay? Those little dashes mean that they are equal. They'll be the same length, always. Okay, well, let's figure out what these sides actually are. Okay, so let's go ahead and just give ourselves a nice, easy number. Nice, easy number we like in math? 1 and 1. We like 1. Okay, well, if these sides are 1, now let's figure out what our hypotenuse of this triangle, of this special right triangle is going to be. So tell me, you guys, using Pythagorean theorem again, what side's my A? We'll go ahead and just call this X for now, because we don't know it.
90.
What side is my A, what side's my B, and what side's my C? Kaylee?
X is C.
Mm-hmm.
A is 45 and B is 45.
Ooh, not the angles, the sides.
Oh.
1.
1 and 1. Good job, good job, good job. Okay, so let's figure out what that C is going to be, because that's going to help us in all the rest of these problems. We got to know what that hypotenuse is. Okay, so I have A squared, 1 squared, plus B squared, another 1 squared, equals my C, which we'll call X squared. Ooh, we're gonna see how this turns out. It's not gonna be pretty. I'm gonna tell you that right now.
Great.
Okay. What is 1 squared, or 1 times 1? 1. Another 1. Equals X squared. Okay. Just like in our last example, don't move these ones, combine these ones. They're on the same side. So what does 1 plus 1 turn into? 2. Not too hard yet, right? Okay, now here comes the ugly part. What's the opposite of square? How do I get rid of the square? Square root. Okay. So our hypotenuse in a special 45, 45, 90 triangle is always root 2.
Root 2.
So that's how we found this special right triangle. Okay, so the sides of a special right triangle, in fact, draw it again where it's not so messy. Let's go ahead and draw ourselves another one. One that we can easily refer to. Okay, we have our 45, Our two sides are 1, 1, because those are equal to each other. And then we just found that our hypotenuse is root 2. That guy doesn't change. Okay, those sides are not going to change. They might get multiplied to make it like bigger, but like as small as it'll go will be 1, 1, and root 2. Okay. Alrighty, let's go ahead and learn about our other special right triangle. Okay, draw yourself a right triangle. This time make one of the legs small, one of the legs long, just like that guy right there. Alright, this guy is our 30, 60, 90 triangle. Well, there's our 90. Okay, our small angle, or the one that's opposite from our small side, is 30. Good. And our other angle that is opposite of our longer side is 60. Good job. 30, 60, 90. Okay, well, here is our fun rule about the 30, 60, 90 triangle. Okay, we know that our small side, right, this small side right here, is always going to be 1. Or let's say it's 1. Okay, and then in the 30, 60, 90 triangle, our hypotenuse, we always know is double that side. Well, what is 1, or what is double of 1? Or 1 times 2? 2. Okay. That's a little different than our 45, 45, 91. Which side are we solving for this time? A, B, or C?
B.
Sure, solve for B. Okay, let's find what that missing side is using Pythagorean theorem. Okay, Jameson tells me it's our B, so I'm gonna go ahead and make A be our 1, B is X, and C is 2. This time we know what the hypotenuse is. Okay, let's plug it in. 1 squared plus X squared. This time equals 2 squared, right? The 2 is in the C spot. Not solving for C, we're solving for B this time. Alrighty, what is 1 squared, you guys? 1 times 1? 1. Don't know what X is, can't square it. Ooh, 2 squared? 2 times 2? 4. Beautiful. Okay. Awesome. Now, both my numbers aren't on one side. I need to move the 1. How do I move it? What's the opposite of plus 1? Minus 1. Subtract. We get X squared equals 3. Ooh, how do I get rid of my square root? Or, excuse me, my square? Square root. So we know that the missing side of this special right triangle is root 3. Okay, so let's draw ourselves a nice prettier one that we can refer to. I'm even gonna flip my page to the side to give myself some more space. Okay, so here is my 60, because that's opposite of the bigger side. 30 is opposite of the smaller side. We know that the small side is 1. The hypotenuse is just 2. And then my other leg is root 3. Okay, we have both special right triangles that we are going to refer to. Whoa, where'd it go? We have our 45, 45, 91. We have our 30, 60, 91. Okay, now here's what we're going to do with these triangles. Like I said, their degrees don't change. We're just going to scale them. What we call is scaling them. Think of it like making this triangle bigger or smaller. Okay, so let's go ahead. We're asked to find the missing side lengths, but we don't have to use Pythagorean theorem anymore. Okay, because we know what these sides already started out as. Okay, so first of all, tell me for number 7, you guys, is this a 45, 45, 90 or 30, 60, 90?
I reckon it's 45, 45, 90.
It's a 45, 45, 90. Hence the 45 right there. Okay, so let's go ahead and remind ourselves what the sides started out as. Okay, well, 45, 45, 90 started out as 1, 1, and root 2. Well, wait a second. How did we go from 1 to 3? What did we have to multiply? 1 times something equals 3. Oh, look at that. That was 3. Okay. Now here's what we do. We just do the same thing to our missing sides. Y equals, same thing, 1 times 3. So what is my y side going to be? 3. Okay, so our y equals 3. I'll write that in a different color even. Y equals 3. Okay, now here's where you might get a little freaked out, but don't overthink it. My x needs to be root 2 times 3. Okay, well, what is root 2 times 3? It's just this. The 3 goes out in front, becomes 3 root 2. So my missing sides, that became 3, and that became 3 root 2. Because we just multiplied every side by 3. Kind of weird, kind of weird. Just got to figure out what it's being multiplied to, then do the same thing to every side. Alrighty, alrighty. Okay, let's look at number 8. Which one is this guy? 45, 45, 90 or 30, 60, 90?
45, 45, 90.
Thank you. 45, 45, 90, which means our sides started out as 1, 1, and just root 2.
There's a 4.
Ooh, yes. What multiplied to the root 2?
4.
Okay, so we went from root 2 to 4 root 2, which means we had to multiply it by 4. Well, that's easy. We're just going to multiply all of our sides by 4. Okay, so first let's do our n side. Well, what is 1 times 4? What is my n going to be? My n side. What is 1 times 4? 4. So the n side is 4. Oh, look how easy this is. Let's do the same thing for the m side. It started out as 1, so I need to take 1 times 4. What is my m side? 4. So don't overthink it. Find what it multiplied to change the one side, and then you just multiply it by the same thing to find your other sides. Okay? We didn't even have to do Pythagorean theorem on these guys.
This would be useful for making bridges.
Probably. Okay, last 2 examples. Still with our special right triangles. Ooh, which type is this one? 45 or 30, 60, 90?
30, 60, 90.
Oh, good. I'm glad you guys got that. Okay, so this one is a little different because our sides aren't the same. So let's see what they started out as. Okay, well, our small side, or the side across from my 30, started as 1. Our hypotenuse started as 2. And our other side that we solved for, remember, started as root 3. Okay, well, we went from 1 to 2. What do we have to multiply to 1 to get 2? 2. Don't overthink it, it's just 2. So our first side, we started at 1. We multiplied it to 2 to get 2, which means we're going to multiply by 2 to each side. Okay, let's do our a side first. A started out as 2, but I need to multiply it by 2 to get my final side. What is my a side going to turn into? What is 2 times 2?
4.
4. So that side's going to turn into 4. Okay, let's do our b side. And don't overthink this. We started out as root 3, but then we have to multiply it by 2. Okay, well, when you have a number that you're multiplying by a radical, guess what? It just becomes that number in front, then the radical. So 2 root 3. Nice, nice. Not too bad, huh? Once you know how they started and then what they multiplied to change them, becomes pretty simple after that. So let's try it one more time. Last example. Okay, what type of special right triangle is it?
30, 60, 90.
30, 60, 90. Nice. Okay, which means we can identify how the sides started, right? Our small side across from 30 started as 1. Our hypotenuse started as 2. And our missing side that we solved for started as root 3. Okay. Well, how did we go from 2 to 4, you guys? What did we multiply to 2 to get 4? 2. Nice. I love that. So our first side started as 2. Then we had to multiply it by 2 to get 4. That's how it changed, which means we're going to multiply every side by 2. Okay, let's start with our x. Why not? That started as root 3, but then we have to multiply it by 2. What is my x side going to be? Don't overthink it. When we multiply a number by the radical, the number just goes in front.
So it would just be 2 square root of 3.
Love it. 2 root 3 for my x side. Love it, love it. Okay, now let's do the y side. The y side started as 1. Then I have to multiply it by 2 as well. What is my y side going to be now? 1 times 2?
2.
Just 2?
1. No.
Just 2. 1 times 2 is 2. Beautiful. So once you know how those sides of a special right triangle started, okay, you can easily figure out how they're all going to change. Okay, just find out how they changed on one side, do the same to the other sides. Okay?